Let's find the points on the ellipse x squared plus 2y squared equal 1, where the tangent has a slope 1. So how do we do this? The best approach is to just do implicit differentiation. It's the fastest and the easiest. Another option, because we have an ellipse, would be to solve for y, but then we will have square roots and plus and minus, and it will be quite messy. So differentiating both sides respect to x, what we get is 2x plus 4y dy dx equal 0. 2x plus 4y dy dx equal 0. Okay, we can simplify here a little bit, but basically this gives already the formula for the slope, dy dx. This is negative x divided by 2y. Okay. So if we want dy dx to be equal to 1, that means negative x divided by 2y must be equal to 1. Okay, so that's it. This says that y needs to be equal to negative x over 2, which is the equation of a line. Well, actually, let's keep it like this for now. Okay, these are the points that will work, but we need to make sure that they are on the ellipse. So 1 second about that. We are not done yet. Let me graph our ellipse so that we have an idea of what we are doing. Let's do it by hand because it's an ellipse and we can do it. So remember, the formula for an ellipse needs to be in this format. X over a squared plus y over b squared equal 1. And then a is the length of the axis in the x direction, and b is the length of the half axis actually in the y direction. So let's make it fit into this format. So this is x squared, no problem there, plus y squared over 2 equal 1. But this is still not quite what I need. I need the square engulfing everything, so I'm going to put the square root of 2 instead. Now this will do. No, in this will not do. I need to write 1 over square root of 2. Okay, now it's good. But this gives the length of the axis. So we have a length of 1 on the horizontal. So 1 and negative 1, and 1 over square root of 2. Square root of 2, I know it's bigger than 1, so it's 1.4. So I have something that is smaller than 1. So let's, without being too precise, let's just draw it like this, and that will do. Okay. And now we are saying a function with a slope 1/2, negative slope 1/2, this here, that will be something like this. These are the points y equal negative x over 2. But I'm not interested in all the points. I'm interested only on the points that are on the ellipse. Because for those points, the tangent, even if this picture is not very good, for those points, the tangent is going to have a slope equal 1. Okay, even if with the poor quality of the picture, we see that it's plausible. Okay, so let's finish. Let's find the precise points where this happens. So I have y equals negative x over 2, and I have x squared plus 2y squared equal 1. Those two conditions. So that means x squared plus 2 x over 2 negative x over 2 squared equal 1. So that means x squared plus x squared over 2 equal 1. That means 3/2 x squared equal 1. Let's move it over here. That means x squared equals 2/3. That is x equals plus or minus the square root of 2/3. Because we have this relation y equals minus x over 2, I have two options. So square root of 2/3 and then negative 1/2 square root of 2/3. That's the first. And the second option is with minus square root of 2/3 and then plus 1/2. I need to change the sign. Square root of 2/3. And these are the 2 points. And just to make sure that what we did is correct, I plotted the 2 points that we found. And we can see here the ellipse. I drew the ellipse and the other condition that y has to be equal to negative x over 2. And then the expressions that we got for the 2 intersection points. And there we see that they are clearly on the ellipse. And it looks like definitely the tangents there are going to have slope equal to 1.